Hi guys, I'm back. Okay, here's our next one, literal equations. So what are literal equations? It is equations that have many variables. Equations that have many variables. But it's the same steps. So real quick, I want you, if I asked you to isolate for x, that means solve for x. And over here, if I ask you to isolate for x, that means solve for x. So how would you do these two? Pause it and then check back in and see if you get what I get. So over here, we know we're going to add 5 to both sides. And I have 2x equals 18. And then I divide by 2, and then x equals 9. Notice the only two steps that we're using are additive inverse and multiplicative inverse. That's it. That's the steps we always use to solve equations. Additive inverse, multiplicative inverse. So it's the same thing. Even though it's a literal equation, I'm going to solve it the same way. So I've got to get rid of this negative b. Additive inverse. Add b on both sides. And I have ax. Now, we have to remember, can c and b be combined together? No, they're two separate terms, so we got to keep them separated. B plus C. If somebody's out there asking, can I put it in B plus C, what's my answer to you? Yes, commutative property, you can. And now, how do you get x by itself? We divide by A. So I'm going to divide everything by A. My A's cancel out, and I'm left with x equals B plus C all over A. Okay? Now, in your journal, I want you to write here and identify the similarity and differences between the two equations. So I'm going to be looking for this in your journal. Make sure this is filled out. I'm not going to tell you what's in here, although we're talking about it. But I want to see you take a minute to write down how they are alike and how they're different. Okay, now let's do some practice problems here. When I say isolate, that means solve. So when you say solve for W, it's the same thing, I'm isolating. Remember, if you're solving for W, I always want what you're solving for on the left-hand side. So we may be using symmetric property here. So if I want to solve for W, I got to get rid of L, so I'm going to use divide both sides by L, and I get A over L equals W, symmetric property, and I get W equals A over L. Okay? So we can change formulas. In fact, I think you did this in science with density. So if I'm solving for distance equals rate times time, and I want you to solve for time, I'm going to divide both sides by R, and I get D over R equals T. So time equals distance over rate. And that's my final answer. Now, look at number 5. I'm solving for H, so I need to get rid of both L and W. I can do it at the same time. Over L and W. Over L and W. My L and W's cancel out, and I'm left with H equals V over LW. Okay? Look at number 7. If I want to solve for C, I got to get rid of this negative S. So I'm going to add S on both sides. And M plus S equals C. I can't combine MS, it's M plus S. So C equals M plus S. There. Okay? Oh, real quick, let's look over at R, number 6. If I want to get R by itself, I got to get rid of pi, so I'm going to divide by pi, and I get R squared equals A over pi. This is R squared. I want R by itself. So how do I get R by itself? Well, we ask, what's the opposite of squaring something? Square root. Square root. So R equals plus or minus the square root of A over pi. It's plus or minus because it can be, you can have, it's square. So like, negative 6 squared is positive 36. So this can be a positive and negative value. So R equals plus or minus the square root of A plus pi. Let's look at number 8. If I solve for M, I'm going to use multiplicative inverse. So I get V over 1 times V. My V's cancel out, and I'm left with M equals D times V. So all I've done is I've used two properties on 1 through 8. I've used additive inverse or multiplicative inverse. Now let's look at multi-step problems. So look at number 9. The first thing is I got to clear out my fraction. How do you clear out 1/2? You multiply both sides by the multiplicative inverse, which is 2 over 1, or just 2. So I get 2a equals b times h. My 2's cancel out. I'm left with bh, and 2 times a is 2a. And now to get h by itself, I divide both sides by b. B's cancel out, and I'm left with h equals 2a over b. So if you know your two properties, multiplicative inverse, additive inverse, this is easy breezy. Let's look at number 11. I'm going to clear out my fraction first, and to do that, I'm going to multiply both sides by 2, multiplicative inverse, and I get 2k equals mv squared. I'm solving for m here, so I'm going to get rid of v squared, and to do that, you divide both sides by v squared. And now m, my v squareds cancel out, and now m equals this right here, 2k over v squared. Okay? All right. Let's take a look at number 13. If I want to solve for w, so I got to get rid of this whole term first. And to get rid of a whole term, additive inverse. I'm moving that whole term to the other side. So I'm going to subtract 2l on both sides. Can I combine p and negative 2l? No, two separate terms. So I have p minus 2l equals 2w. And if I want to get w by itself, I got to get rid of that 2, multiplicative inverse. So I divide both sides by 2, and I get w equals p minus 2l over 2. And the great thing about this video is if you didn't catch it the first time, you can pause it and go back. All right, let's look at number 15. And the only way to get good at these guys is practice. It's practice. I give you more problems, I throw them out there, and then you just practice and make sure you understand them. So 15, if I'm going to solve for x, I got to get rid of this plus b term. How do you get rid of a whole term? You do additive inverse. So you're going to subtract b on both sides. Y minus b equals mx. And to get x by itself, divide both sides by m. M's cancel out, and I'm left with x equals y minus b all over m. And that's my final answer. Okay? All right, let's take a look at number 17. Number 17. So I got to get rid of that 5/9. How do I get rid of 5/9? Multiplicative inverse. Multiply both sides by 9 over 5. 9 over 5. My 9's cancel out, my 5's cancel out, and I'm left with 9/5 c equals f minus 32. I didn't distribute that 5/9. That's just more work. So the first thing I did is I cleared out my fraction. And now to solve for f, you add 32 on both sides. And f equals, that's one term, 9/5 c is one term, and plus my constant term of 32. And that formula, of course, is going from Celsius to Fahrenheit. All right, last one we're going to do together is number 18. All right, I want to clear out my fraction first. I don't want to distribute because then it's just, it creates more junk that I've got to get rid of later. So I'm going to get rid of that 1/2 by multiplying by 2, and I get 2a equals h times b1 plus b2. I do not want to distribute. That just makes it more complicated. So if I want to get rid of h instead of multiplying them, I'm going to divide to get rid of h. And now I have b1 plus b2. I've just done the symmetric property kind of in my head here. I'm moving this term over. b1 plus b2 equals 2a over h. This is one term now. Does everybody see how that's one term? And then if I want to get b1 by itself, I got to get rid of this positive b2, so I subtract b2 on both sides. And I'm left with b1 equals 2a over h minus b2. There are two separate terms there. Okay? All right, so we've done some examples together. I know that went fast. Go back and pause and look at it. And if you struggle, you do kind of do some in the journal, and I can check those or look over your homework. And then if you have questions, come and see me. Good luck.